Dear students, we are discuss about the inequivalences of the classical mechanics. That is, what are the inequivalences? Let we describe the classical mechanics and the quantum mechanics firstly, and we discuss about the what are the inequivalences of the classical mechanics. Okay. Classical mechanics. Classical mechanics describe the motion of macroscopic particles such as planet, star, moon, lump of clay, as well as microscopic particle, microscopic particle such as motion of bacteria, motion of bacteria, virus. It it describes the motion of it describes the motion of particle. It describes the motion of particles in non relativistic cases. Non-relativistic cases or limit. What is the non-relativistic limit? That is, velocity of the particle is very less than the velocity of light. Newtonian mechanics. Newtonian mechanics based on the concept of number A, absolute space, number B, absolute time, number C, absolute mass contained in Newton's law of motion, that is F equal to ma. Due to certain limitation, of classical mechanics, the following phenomena could not explain in physics. Number first, it could not explain the spectrum of black body radiation. It could not explain the black body radiation. Let's discuss about this. According to classical theory of radiation. According to the classical theory of radiation, the energy density of blackbody radiation is the energy density of blackbody radiation is U mu comma T equal to 8 pi by CQ into mu square kT. So total energy obtained by the integrating this, so integrating U mu comma T equal to 8 pi by CQ mu cube by 302 infinity comes to infinity. Here the total energy of blackbody radiation comes to infinity, but experimentally total energy should be finite, and hence if the total energy is finite, then the energy is the measurable, and hence energy can be measured. So energy is measurable. Number 2, it could not explain the stability of an atom. It could not explain the stability of an atom. Okay, students, it could not explain the stability of an atom. According to classical mechanics, an accelerated electron inside the nucleus of atom lost its energy in the form of radiation. So its energy decreases continuously. So the radius of an electronic orbit also decreases. So the radius of the electronic orbit is also decreases. An electron jump inside the nucleus, and electron jumps inside the nucleus and become atom is unstable. An atom becomes unstable. In real atom is but in real atom is stable. Number 3, it could not explain the pair production phenomena. It could not explain the phenomenon of pair production or pair production phenomena. It could not explain the pair production phenomena. For pair production, when high energy rays passes through the nucleus of a heavy element, then this ray is disappear. Why it is disappear? Because of the ray emits the particle and antiparticles. That is the main points for the pair production. So for pair production, when high energy ray passes through nucleus of heavy element, the ray disappear with emission of particle and antiparticle. What are the antiparticle? That is electron, proton, antiproton, positron, antipositron, neutron, etc. This phenomena could not explain the classical mechanics. According to classical mechanics, this phenomenon could not explain the pair production, and for pair production, mathematically pair production is h mu. This is the when high energy ray passes through the nucleus of heavy element, that means the frequency that there is a high energy. This is the energy equal to h mu is the energy of the incident radiation. So high energy ray passes through the nucleus of heavy element, then the ray is disappear with the emission of the particle and antiparticle. That means the emission of particle and antiparticle. So h mu equal to this. H mu, what is the h mu? H mu is in the energy of the particles. Okay, which number? Number 4. It could not explain the tunneling effect. This is the most important topic in quantum mechanics. What is tunneling effect? And we discuss about the one-dimensional barrier potential in the next chapter. Here we only discuss about what is the tunneling effect, why the classical mechanics could not explain this tunneling effect. So what is the tunneling effect? The process of crushing the high energy barriers with low energy particle is called the tunneling effect. It's called tunneling effect. The possibility, that means the tunneling effect, the possibility of tunneling effect, the possibility can be only with quantum mechanics. Example, let's see example. Ejection of less energy alpha particle from higher bending energy of the uranium nucleus. Uranium 92 to 35. That is the uranium nucleus. Number 5, sorry. It could not explain the photoelectric effect. For photoelectric effect, this is the h mu and its image the kinetic energy 1/2 mv square, and this is the surface. So, according to the classical mechanics, the kinetic energy Ke of emitted photoelectron depends in intensity of radiation, but independent of the incident frequency. But according to the Einstein photoelectric effect, according to the experimental observation, that is Einstein photoelectric effect observation, the kinetic energy of emitted photoelectron depends on the frequency of incident radiation. Not in intensity. That is h mu equal to phi naught plus 1/2 mv square. Phi naught is a work function, m is the mass of the electron, v is the velocity of electron. So from this h mu, from this, therefore the kinetic energy is directly proportional to the h mu. So here we discuss about the threshold frequency in the experimental observation, that is the photoelectric effect, but in classical mechanics we cannot explain the threshold frequency. Number 6. It could not explain the discrete atomic spectrum. According to classical theory, the energy exchange between the atom and radiation field must be continuous. The energy exchange between this atom and the radiation field must be continuous. But atom absorb and emit the energy in the form of h mu, that is E1 minus Et equal to h mu. So we can write this way. Number 7. It could not explain the Zeeman effect. It could not explain the Zeeman effect, Stark effect, etc. Dear students, this Zeeman effect and Stark effect already we discussed about the lower classes in 11 and 12. So you are going to study this. This is the most important. And number 8. It could not explain the Compton effect. Students, what is the Compton effect and why the Compton effect could not explain here? So I can summarize something. This we have the Compton effect, the observed wavelength in scattering radiation. The Compton effect, the observing wavelength in scattering radiation is equal to lambda minus lambda. This must be equal to this. This is the change in the wavelength, and this is the observed wavelength and the scattering wavelength. That must be equal to S by m naught c. That must be equal to S by m naught c 1 minus cos theta. This is the lambda prime is the scattering particle wavelength, and lambda is the incident particle wavelength, and m naught is the rest mass, and theta is the angle of scattering. According to the Compton effect, according to the classical effect, the wavelength, this scattering wavelength and this incident wavelength must be equal in a classical mechanics. That means d lambda equal to 0, but in Compton effect the d lambda is this. And number 9, it could not explain the variation of the electrical conductivity, that is the superconductivity. Note this, student, it could not explain the variation of electrical conductivity of solid. And another is it could not explain the phenomena of pair production. Here is a lot of the inequivalences in a classical mechanics. So dear students, please my subscribe channel, and I will provide the further more video for your further study. Next day we are discuss about the wave matter duality of radiation, and what is the Planck constant, what is the Heisenberg uncertainty principle, what are the application of the Heisenberg uncertainty principle. So please subscribe my channel and like and share. Thanks for watching my video. Thank you.